Let's look at a more practical problem where probability has an interesting application. So the cops are out doing random breath tests on some stretch of highway where previous experience has revealed that 2% of the drivers that drive on that stretch of highway are over the legal alcohol limit. So they're drunk. They're above 0.05 blood alcohol content, if you want to look at it that way. So suppose the cops have a breath analyzer. Right? There's a 98% chance that the analyzer will correctly detect a drunk driver. That is, if the driver is over the legal limit, there's a 98% chance that the analyzer will say that the driver is over the limit. If the driver is not over the limit, i.e. their blood alcohol content is low, there's a 96% chance that the analyzer will correctly detect that the driver is not drunk. So the question we're going to ask is, how useful is this breath test analyzer? How good is it? Is it actually doing a good job? There's a lot of information in this question that we've kind of got to dissect, and it's all within the framework of conditional probability. So we really do have to start assigning some notation to this. So let's just sort of pick out some of the information that's useful first. There's this 98% chance. Correctly detect drunk driver. There's a 2% chance drivers are drunk, right? That's sort of overall. And we've got this not drunk, 96% correct detection, right? So we've got to try and put this into maths. So let's assign some notation. Let's say T is a positive test result. So positive means that in this case, blood alcohol content is greater than 0.05, for example, right? The driver is said to be drunk. That might be a very negative thing for our driver, of course. Let's also write D for actually drunk. So that's the driver is actually truly over the blood alcohol limit. So this should be measured. And this is actual. All right. So now we can say probability drunk. That's one of the first pieces of information we're given. That's 2%. 2% of drivers are drunk. So we can just interpret the percentage as a probability. So PD is 0.02. All right. Obviously, the probability of not drunk complement, or probability that you're sober, is 1 minus probability drunk. We've now got to get into the conditional probabilities that we've been given. We've been given the probability that a positive test result is returned if the driver is drunk. If the driver is drunk, there's a 98% chance that the analyzer returns a positive result, right? Correctly detects, in this case, is a positive result. So, probability of positive test result, given that they're drunk, is 98% or 0.98. All right. The other conditional that we're given is the probability of not drunk. So given not drunk, that the test result is negative now, right? So we've got it's not positive, right? Because a positive test result is when we say that blood alcohol content is above the limit. So this is true T complement is 96 or 0.96 if we think of it as probability. Now we can use our complementary events. Remember how complementary events work for conditionals. It's like they work on the first component. All right, I think that's all the information we've got from the question. Let's interpret these ones. That's the probability that we get a negative result for a drunk driver. So that is, old mate's driving drunk, he gets pulled over, breath out, and the machine says he's good to go, right? 2%. This one is the probability that we get a positive test result given that the driver's sober. That's 4%. This is kind of the bad situation here, because that's busting innocent people. This one's also not too good because people are, 2% of people are getting away with it. They're being let back out on the roads. So that's not great. We can work out the probability of a positive test result overall in all circumstances. Any random driver gets pulled over, what's the chance they blow over the limit? We can use the law of total probability. We want the probability of a positive result. We've got all these conditionals. We've got the probability that they're drunk, so we just use the law of total probability. So that's a positive test result given that they're drunk times the probability that they're drunk plus the probability of a positive test result given that they're sober, drunk complement, multiplied by the probability of drunk complement or more sober. Right, so we can actually stick the numbers in this. 0.02 times 0. Let me just stick it in the correct order. 0.98 times 0.02 plus probability of 0.04 times drunk complement. Well, that's 0.98. That turns out to be 0.058. Now that's about 6%. Right, so 6% or 6 in 100 people that get pulled over, they're getting busted, whether they're innocent or not, or whether they're guilty or not. So that's any randomly selected driver, 6% chance of blowing over. What we're interested in is actually the probability that the driver's drunk, given that the test says so, right? The driver being drunk given a positive test result. So old mate gets pulled over, he blows in the breatho, he returns a positive result. What's the probability that old mate's actually drunk? That is P D given T. Right, so obviously that's a reversal of what we've been talking about, right? So we've got things like positive test given drunk and so on, right? So we've got to use Bayes' rule here. So we can either remember how conditional probability works, or we can remember Bayes' rule. So we know that that's the probability of drunk and positive divided by probability positive test, right? Or P T given D times the probability of D divided by the probability of positive test, right? We've got all of these items. We've got this one, we've got the probability of positive test. We just computed that using the law of total probability. We were given the probability that they're drunk anyway, right? So that's the 2% of drivers. And we've been told the the successful testing, right? Positive test result given that they're drunk. So we know all of this information. So we can stick the numbers in. Right, and I'm reliably informed that this is actually 1/3. Now that's interesting. The probability of a driver actually being drunk given a positive test is 1/3. Okay, you might not think much of that until you work out this probability. This is the probability that a driver is sober and returns a positive result. And that's terrible. That says that 67% of all of the drivers that are identified as over the limit are sober. So that is some rando gets pulled over, does the breath test. There's a 6% chance that the breath test says positive. There's a 67% chance that old mate is not over the limit. So that this breathalyzer machine is probably almost completely useless for law enforcement purposes. It's completely inaccurate. It will identify far too many false positives. That's an unacceptable level of false positives.